Hey everybody. I didn't know I'd started recording yet. This is SciPaw, Science and Pause. Let me give you an example. Pause. Alright, here we go. Alright, this is SciPaw, the show where we check out interesting scientific concepts with our friendly little furry friends at Pause. Okay, as you know, the show goes by somebody sending in an email and asking me an important scientific concept. So let's check our email. Alright, checking our email, we got one for today. Impressive. Dear SciPaw, I'm wondering about the moon, the following. Number 1, place connections. Number 2, social, economic, and political policy aspects. Number 3, time, deep and shallow elements. Number 4, show me the evidence, SciPaw! Number 5, in your usual awesome fun style of presentation. Thanks, SciPaw. I'm y'all's biggest fan of all time. XOXO, Science Mama Forever. Wow. Okay, cool.
You're welcome for the email, honey.
Oh, Mama!
Well, it's not like you had any other emails.
Okay, good point. Alright, moving on. Alright, so today we're going to talk about the moon. Now, I just need to say one thing. I know that a lot of my viewers love the Lord, as do I, and they believe in a 6-day creation. No problem if you do. I'm just going to go off of some scientific concepts that might sort of merge those two. Maybe not. No problem. I'm not really trying to fight science versus religion. I'm just showing some of the evidence. Alright, here we go. Now, one of the main theories out there says that our solar system started off as a giant gas cloud of dust and gas. I already said gas. Oh well. Now, one idea for that cloud to start condensing is that there's a supernova in the area, and it blew, and it started hitting and pushing up against that gas cloud, which started causing it to condense. Now, after it started condensing, those particles got closer and closer, and static charges started bringing them together, like honey and me. As you may have guessed, those static charges started creating lightning, and lightning fused those dust clouds into little bitty rocks. Now, them little bitty rocks, they started condensing down because of gravitational pull, and then that gravitational pull caused bigger and bigger rocks to start condensing down together. Based on some of these oldest rocks we've found through radiometric dating, it appears that this all happened about 4.8 or 4.6 billion years ago, quite a while ago. So these rocks came together to form what we call the brand new baby Earth and the rest of the solar system. So happy birthday. Now, as these bodies got bigger and bigger, you started seeing them collapse down into spheres. Also, there were still tons and tons of rocks in the solar system just flying around, smashing into these bigger and bigger spheres. Now, one of the big ideas about how the moon formed was that the Earth was still pretty small, and there was another proto-planet hauling around, and it was about the size of Mars, as Mars is today. Now, this protoplanet struck Earth, sort of on a glancing blow, sort of like when Mama gets mad about being putting her delicates in the dryer.
I heard that.
Well, I didn't say nothing. And you'll notice after that collision that pretty much the Earth turned liquid. Yep, that much energy causes things to liquefy. So that caused a lot of material to be ejected out into space around Earth's orbit. A lot of people think that that material condensed down again to form what we now call the moon. Are you with me so far? I sure hope so, because we just talked about how the moon started off as tiny little specks of dust, and it grew and grew and crashed into Earth, and material flew around, and then now we have this moon that starts solidifying around the Earth. Let's move on to that. Starting with about 4.5 billion years ago, you see the moon start to solidify. Now then, about another 0.2 billion years after that, the south pole of the moon was hit by a giant asteroid, making the Aitken Basin. Now, there was so much material still left over in the solar system that there was tons and tons of bombardment until 3.8 billion years ago. And around 3.8 billion years ago, up until about 1 billion years ago, there was some volcanic action as the core of the moon was still extra hot, and the crust was thin from all the recent bombardment. Now, this formed the mare, or the dark patches that you see on the moon. Obviously, there are still tons of bombardment still, lots of meteors striking the moon, and then up from about 1 billion years up to today, there was less and less and less bombardment, up until what we see now today. Now I know what you're thinking. SciPaw, what am I looking at here? Alright, the darker spots are what we call mare. Isn't that right, Kiva? Yeah, these darker spots are made of basalt, and they're darker in color because they contain a lot of iron, pyroxene, olivine, and ilmenite, along with volcanic glass. Alright, the lower spots are what we call the highlands, and the highlands are anthracite, and they're light in color because they are made of plagioclastic feldspar. Plagioclase. Gosh dang it, Kiva. Are we going to have to redo that? Nah. Here's a sweet close-up view of the moon by Apollo 17 as they orbited it. Notice at the bottom the mare and at the top the highlands. This close-up view lets you see the contrasting elevations. Pretty awesome. Now maybe you've seen this sweet photo by Apollo 11. It's a picture of one of the astronauts' footprints in the soil, or regolith, on the moon. Now you may notice how cleanly cut it is. What's going on? Alright, I'll tell you. The crystals of this soil are very angular or jagged. This can be seen easily with this electron scanning microscope. You know, on Earth, they're actually pretty rounded because there's a lot of weathering going on. But on the moon, nope, not so much. There's not very much weathering going. Now, the soil is created from the meteor impacts. As they strike the surface, they vaporize a lot of the moon, creating a lot of very small particles, and they return and settle back down to the moon's surface as a fine, jagged soil. Just the way I like it. Alright, so there's a history of the moon, but it doesn't stop there, you better believe it, because we're involved. So are these guys. Okay, so here's some pictures that I've taken of the moon. Let's take a look. It's up there, Sadie. Yep, okay. So we have a crescent moon. Yeah, obviously the moon's busy changing phases. It's over there, Sadie. Yep, changing phases. Also, we have a solar eclipse occurring. That's right. The moon goes in between us and the sun. Pretty nice, isn't it, Sadie? And then we also have a lunar eclipse. Yes, I like that one too. Okay, thank you very much. Now, in order to continue our story about the moon, we need to take a slight turn, and a very real turn. World War II. During World War II, many of the world's countries were pitted against each other. There was one large competition that happened between the two, besides just winning the war, and it was the development of the nuclear bomb. This weapon converted a little bit of mass to a whole bunch of energy. It was very, very destructive. While the Americans were the first to develop the nuclear bomb, Russia soon followed, as did several other countries. However, one area that the Germans did succeed in was building a rocket. That's right, they could send a payload across the ocean and destroy targets. Now, this rocket could travel hundreds of miles and was very hard to detect and track and stop. Towards the end of the war, German scientists were being captured left and right by both Russia and the United States. Most notably, Werner von Braun was captured by the United States, at which point we asked him to help us build some rockets, and he kindly replied, "Ja." And that's yes in German for those of you that don't hablo Germano. Now this is where it gets interesting because both the Russians and the Americans had rocket scientists who could help them build rockets that could take off and actually work. And I bet you can guess what they wanted to put on top of those rockets. That's right, puppies. But mostly nukes. Maybe a puppy or two. But nukes. Before rockets, the only way to get a nuke to your enemy was through a plane. Well, that was the best way. A train or carrying it would sort of suck, but doable. But an airplane was by far the best way. However, the main problem with an airplane, believe it or not, is that it could be shot down pretty easily. Not so with a rocket. Knowing this, the Russians developed the R-7 rocket. It was capable of carrying a nuclear missile thousands of miles. Now, for those of you who don't know your Russian very well, let me loosely translate for you what they're saying. With my best Russian accent, of course. Alright, everyone, we want to put on top of this here rocket a nuclear bomb, and let us be able to send it to wherever we want. maybe to a swimming pool, maybe to a birthday party. And there will be a big bang. Good job, everyone. Now, the Soviet Union, or Russia, and the United States were not the best of friends. Communism and democracy were at war with each other. Now, in 1957, the Soviets launched Sputnik, the very first satellite that orbited the Earth. This was done with the same R-7 rocket. Not only did this freak many Americans out that the Russians were ahead and that they could deliver a nuclear warhead whenever they wanted, it also showed that the Russians were doing well in their science and engineering, as they were beginning to explore space, the final frontier. Thus, the space race began. Americans began working feverishly to get rockets up into space, and to solidify the ability to deliver nuclear warheads. Now, I know what some of you are thinking. What the heck, SciPaw? Tell me about the moon! Well, hold your horses, I'm getting there! Now, I'm going to show you a timeline of significant events that happened during the space race. We already talked about Sputnik being launched in 1957, October 4th. Also, November 3rd, they launched Sputnik 2, which carried a small dog. Congratulations. They're the first ones to send an animal out into space. Now, finally, the USA got its act together, and Explorer 1 was the first American satellite to reach orbit. Next, Luna 1 was launched by the USSR as the first man-made object to orbit the sun. And then we see Luna 2 being launched, right here. And that's already in 1959. And it impacts the moon, the first object to do so. Finally, the USA started getting some firsts. First successful weather satellite. First spy satellite. Next, in 1961, Yuri became the first man to go into space. Just less than a month later, Alan B. Shepard became the first American in space. Now, October 1st, 1958, NASA was formed. Here we go. September 12th, 1962. President Kennedy gives his famous speech where he encourages us to go to the moon. You know the speech. We choose to go to the moon, not because it's easy, but because... Okay, that was horrible. Here's the actual recording.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Yes! Yes! It's just beautiful. Thank you, JFK. Thank you so very much. All right. Okay. Get yourself together, SciPaw. We can do this. All right. Now, that call to the moon was what nailed down the space race. The Americans were going, and the Russians were on it as well. The race picked up. Now, remember, this is 1963. We still have a little ways to go. Let's push on. In 1963, the USSR sends the first woman up into space. Valentina Tereshkova. Sort of a hottie. Next, in 1965, the USSR has Alexei do 12 minutes of the first spacewalk in space. He actually leaves the vehicle and wiggles his toes. Just a short amount of time later, in June 3rd, Ed White does the first American spacewalk. Now, I know what you're thinking. Bring it home to me, SciPaw. Show me what this all connects to. Wait. Oh my gosh, it's 5. Oh, I gotta send a text. Sorry about that. Sorry, Martha. Still have a ways to go. I'll have to miss yoga. My bad. Oops. Okay. Alright, sleeves are back up. Okay, I'm gonna bring it home for you. Basically, the Russians and Americans were locked neck to neck in this battle to see who can make it to the moon first. Different stages were accomplished by different programs, at different times. Overall, it looked like the Russians were doing much better, but in 1966, they lost their main program director, Korolev. Now, this guy was really in charge of stuff, and he was kicking butt for the Ruskies. However, after he moved along, the Russians went with the N-1 rocket to send their people to the moon. They had lots of problems with that particular rocket. Crash after crash after crash. Failures to launch just didn't work out. Meanwhile, the Americans with their Apollo program were doing excellent. They were making milestone after milestone with rendezvous, going around the moon and back, and then actually descending towards the moon and then coming back up. But the Americans weren't out of the woods yet. The Russians had a large N-1 rocket ready to go in July, so the Americans needed to push up their schedule, and they tried to launch as quickly as possible. So on July 16th at 8:32 a.m., the Americans launched Apollo 11. It took Apollo 11 about 4 days to make it to the moon, and once they did, they got into their lander, the Eagle, and then they started to descend down. Now, as most of you know, there were issues with their landing spot. It was a large crater, lots of boulder fields, so Neil Armstrong took over manual control and steered it in very carefully, his heartbeat going up to about 150 beats per minute, and he did it! All throughout the world, men, women, children of all nations watched anxiously as the Eagle landed and as Neil Armstrong prepared to step onto the moon. At 9:56 p.m., Neil Armstrong bravely stepped out onto the moon. Red, white, and blue. Here we go.
One small step for man, one giant leap for mankind.
Yeah!
One small step for man.
Woo!
Giant
Woo! Yeah! Yeah! Ha ha! Whoa! How'd I get here? Just kidding. Lightning strike, power outage at my old place. No business like show business. So you might be wondering, is the story over? Well, not quite. Couple things. First off, NASA sent another 6 missions to the moon through Apollo 17. Only 5 of them made it. Apollo 13 had to turn around partway through. I'd like to show you by using ArcGIS Online where the Apollo missions landed. Zoom in here on the moon, and as you can tell, Apollo 11, A11, landed here in Tranquilitas. Apollo's 12 landed here. 13 did not land on the moon. It instead went around the moon and back to Earth. Apollo 14 landed near where Apollo 12 site. And Apollo 15, 16, and 17. Next, another important thing that happened was an agreement governing the activities of the moon and other celestial bodies by the United Nations. This happened in the 70s, and we're just viewing some of the text that happened there. The moon shall be used by all state parties exclusively for peaceful purposes. Makes sense. Also notice that there's a discussion about how nuclear weapons or any other kinds of weapons of mass destruction are prohibited on the moon. Very interesting that the space race was largely done in part to be able to harness these weapons of mass destruction, including nuclear bombs, and later they decided, okay, we don't want to mess with the moon regarding this. In the meantime, the Soviet Union focused on sending space stations into orbit around the Earth. That was their big deal for a while. And in 1975, the American Apollo capsule and the Soviet Soyuz capsule both docked in outer space as a mutual respect for each other, and it's taking steps towards peace, which happened later on.
In the history of man.
Alright, couple last things I want to talk about. First off, there were sweet inventions that came out of the Apollo program. For example, quartz watches. You know that you have one, or at least you used to before you had cell phones. Next, space blankets. Guy that steals a newspaper, not included. Finally, of course, rockets. What is space without rockets? If it wasn't for the space program, then we would not be able to continue our search on into the rest of the solar system and hopefully the universe. All right, that's all the time we have for this time. Thank you so much for watching. And you know what? The space program was awesome. Even though it seemed to start off with war and trying to be able to send nukes to each other, it really brought people together. And overall, as we can see with the International Space Station, people are working together. Keep it up! Hoorah! Wow.
Play your